That sounds silly.
Wait, what'd you say?
All right. One page and then we're done.
In Mario.
All right. No. Go on.
Call of Duty.
No. I see your phones are gonna be mine.
Heard that? Yeah.
Yeah, everybody's.
Yeah.
I don't care.
Wait, I have love projects on my phone.
Wireless headphones?
No, you got
No.
computers in here.
No, like actually. I'll show you.
All right. So, last chapter we talked about Euler circuits and paths.
Spoilers.
This chapter we are going to talk about Hamilton circuits and paths.
Wait. I thought you said it wasn't even
I
connected. You
hate
lying.
that word.
It's different.
Is it
We're
really
gonna
the
talk
same
about the
thing?
differences.
Is it really the same thing?
Shh. No.
Sure.
Goodness gracious. So, Euler said that you had to use every edge once and only once, which means you could use the vertices as many times as needed. Okay, so you could go back to point A 5 times as long as you were taking 5 different lines to get there. Hamilton. Now you can't.
Oh my.
Okay, so Hamilton says we need to use every vertex once and only once. So once you have visited a place, you cannot go back there. But the best part about this is you do not have to use every edge. I no longer need to take every way there. I just have to get there, leave there. So, a circuit is still starting at a place, visiting every place, and going back to the start. A Hamilton path is starting at a place, visiting every place, and ending somewhere else. Okay, so we're going to do a little bit of review with with Euler, and we're going to look at Hamilton paths and circuits. So if you look at graph number 1, would this be an Euler path, a circuit, or neither?
Circuit.
Why?
Because it looks hard.
Well,
They're all even degrees. So A's a 2, B's a 4, F's a 4, G's a 4, E's a 4, C's a 4, D's a 2. So that makes this an Euler circuit.
yeah. Which one's a path?
Okay. Now, the question is this a Hamilton path?
I would say yeah.
Is this a Hamilton
I would say
circuit?
if it's a Euler
No,
circuit,
shut
it's
up.
gonna be a path. Path.
No, shut up. Let me think about it.
Okay, so again, Hamilton says I need to start at a point. I
got
need to trace the edges, touch every point, and if it's a circuit, I can go back home.
Yeah, you can.
Okay? So you say it's a circuit. How am I going, Sienna? A to F. Down. You said where? D. C.
G.
G.
Oh, yeah, G.
B.
B.
A.
A.
Told you.
So
COVID.
this is a Hamilton circuit. Again, did I touch every line?
No.
No, you don't have to. Would you also consider this a Hamilton path?
Yes.
Yes, why? What can I get rid of to make this a path instead of a circuit? You still have to touch every dot, you just don't go back home.
There you go. So just get rid of A to B.
So if you just get rid of this, and I started A and ended B, and I just don't take that last edge home, this is also a Hamilton path. Okay. So, in other words, if you have a Hamilton circuit, you will always have a Hamilton path. Okay, so if you have a Hamilton circuit, you always have a Hamilton path every time.
So, does that mean like every single time we have a Hamilton path, we always have a Hamilton circuit?
No, it does not work backwards.
Okay,
Okay, so it will not work in reverse.
just making sure.
Okay, take a look at graph number 2. Again, go back to Euler. What does Euler tell you? This is a what? Is it a circuit, a path, or neither, according to Euler?
Circuit. Oh, neither.
Neither. No, it's a path, it's a path, it's a path, it's a path.
Should be a path.
Path.
2, 2, 2, 3, 1.
Path.
So this is an Euler path.
Go to D to A to B, B to C, back to D, and then.
Are you trying to do an Euler path?
Yeah.
Oh, okay. I don't care about that right now. We know how to identify that without actually tracing it.
I'm sorry.
But Hamilton, where do you want to start? You said
Start at
E. E to D.
A, B, C.
So this is a Hamilton path,
Can't be a circuit.
but this can't be a circuit. There's no way to get back to E. There's no line that connects C to E, and you can't go through D to get there.
So if there's only a path, it can't be a circuit.
No.
If it's a path, it could be a circuit, but it doesn't mean that it's a circuit.
The circuit.
So here, we had a path and we had a circuit. Here, we have a path, but we don't have a circuit. So a path doesn't necessarily tell me I have a circuit, but if I have a circuit, I definitely have a path. Okay. Take a look at the next one. According to Euler, should I have a circuit, path, or neither?
Neither. They're all threes.
This one's a neither. I've got too many odds. These are all threes.
And the middle one's four.
And the middle one's 40, right? Okay, neither. Can I find a Hamilton path?
Yes.
Okay,
A to B, B to C, C to D, D to E.
okay, so we've got a path. Do I have a Hamilton circuit in this one?
No, because you can't touch the dots again. Correct?
Yeah.
So you can't, because if
You
you,
can't touch the dots again, but there is another way to make a circuit here.
A to D, D to C, C to E, E to D, B, and back to A.
So, not every path is going to turn into a circuit, but there are different ways. So I do have a circuit and a path in this picture. So again, the circuits and paths don't necessarily change. A circuit still has to go back to where you started. A path can start and end at 2 different spots. Graph number 4. Euler, circuit, path, or neither.
Circuit.
This is an Euler circuit. They are all even.
So there's a path.
Okay. You said that there's a Hamilton path.
Yeah, because you said
Okay.
there's a circuit, there's always a path.
Hamilton circuit. There's always a Hamilton path.
Huh?
I said if there's a Hamilton circuit, there is always a Hamilton path. It
Oh,
has nothing to do with Euler.
So,
but there's no circuit, there's a path.
touch A though, right?
Yes.
There's no circuit.
There is no circuit in this one. Because you would have to cross through C twice to make it a circuit. Okay. What about graph 5? Euler, circuit, path, or neither?
Path.
Euler path. You've got an odd here and an odd here. So A and D are both odd. Everything else is even. Is this a Hamilton path or possibly a Hamilton circuit?
Hamilton,
No, neither.
neither.
This one's gonna be neither. Okay. A to B, B to F. How do I get to G? How do I get to D? Okay.
I tried doing A to B, B to C, C to E, C to G, but then you come back up.
Once you get to G, you're stuck.
You're stuck, you have to go back up to.
You'd have to go back up to B, which you can't do. Okay. So this one is neither a Hamilton path or a Hamilton circuit. So what do we got for Euler for the next one?
Neither.
This one should be a neither. Okay.
I think this
You think this one's just a path?
What's it about?
Okay. We got a path. I would have to agree though, this one is not going to be a Hamilton circuit. So, are you noticing any relationship between a graph having an Euler circuit and a Hamilton circuit?
No, not really.
No. Okay. Do you notice having an Euler path or an Hamilton path?
No.
No, there's no relationship here.
Cheat
Okay.
code.
So,
There's no cheat code.
as much as I would love to tell you, it's really easy to determine Euler circuits and paths because you can count the degrees. There's no easy way for Hamilton.
She won't say that in my next period, the next,
The only way that there's an easy way to tell you how many Hamilton is if it's something called a complete graph, which we will learn about tomorrow. But not every graph is complete.
Now you're doing that.
Now I'm doing extra. Yes, Darren.
I was just learning, I was just using real life.
We're gonna talk about it
Tomorrow.
tomorrow when we talk about
Honestly,
No,
everything we've
seriously,
learned so far-
tomorrow
I'm just curious.
we're going to learn about it. We're actually gonna do an example on Homer
To
Simpson.
build your own house. To build your own house.
I figured roads.
We're- So we're actually going to assign numbers to the edges in this chapter that represent like the miles it takes to get from one point to another or the blocks it takes to get from one point to another. So we're gonna find the fastest way to start at a point, visit all of our destinations and get back to that point. It depends. It could be either. So you guys are actually, your project for chapter 6, you need to pick 5 colleges to visit, and you're gonna find the fastest way to visit all of the colleges and make it back
I
here.
gotta be in college. That sounds hard part.
I'm going to DCCC.
DCCC back.
No, I make it,
GTCC back.
so I make you start in Winston,
DCCC.
and you have to leave Winston.
DCCC.
So, yes, you can do DCCC, but I want you to think outside of the box.
DCCC.
If you had to pick like 4
San Diego
colleges
State
that you
University.
really, really want to go to,
DCCC.
So-
San Diego State University.
there you go. Okay, and then you can do it in miles. And you're gonna look it up on Google and figure out how many miles from each point to the next.
University of Cambridge.
It'll be fun.
Fred-
Nobody said you had to drive.
You have to walk.
You can fly.
Oh.
We got whole.
Yeah, you gotta walk to San Diego. Go. Alright. So, this thing hates me. All right. So our job right now is going to be to find all of the distinct Hamilton circuits in this graph. So there isn't one. So when you're finding distinct Hamilton circuits, I want every different way that I can start at A and end at A. So the biggest thing when we're talking distinct is you always want to start at the same vertex. Okay, when I ask you to list distinct, don't start at A and then start at B and then start at C, because you're not necessarily giving me different ones. You could be giving me a same one. and we're gonna talk about that in a minute. So if I ask you to list distinct, I need you to start at the same letter. Okay, so they gave me my first distinct circuit. I can start at A, I can go to B, I can go to C, to D, and back to A. Okay, so A to B, B to C, C to D, and back to A. Beautiful thing about Hamilton though, if you have a distinct circuit, you actually have two. Because A, B, C, D, A is different than A, D, C, B, A. You can also go in reverse. These are two different things. Okay? This would be like A is your home. And you leave home and you go to Bob's house. I picked Bob because it's a B. Then you go to Charlie's. Then you go to Dan's. And you go back home. Okay? It's different if you leave home and go to Dan's and then Charlie's and then Bob's and back home. I don't know. It was the first thing. What do you want? Like Rashawn and Corey and Derek. We don't have a B in here, do we?
Huh?
We don't have a B in here, do we?
Barbaric.
No,
Barbaric.
we don't have a B in here.
Zane does not start with a B.
He wasn't saying, he was
Bane.
calling him.
Bane. We're gonna change his name to Bane.
Yep, I'm not Bane.
All right, Bane.
Mike.
That's a villain.
Mike.
Yes. One of them got you.
They're just trying to tell you you're evil.
Yeah, Zach.
So now we've got Zane, Zach, and Bane. Mike. Don't forget Mike.
Yeah, Mike.
Call him Mike.
Mike and Mike.
Oh,
Mike and Mike.
can we what?
Mike Gonzalez started that.
So I need a completely different way to start at A, visit all of my places, and go back.
A, C, D, B.
Okay.
Wow. She took-
A, C, D, B, A.
Work in reverse. A,
Okay.
B, D, C, A.
I can do this one in reverse. A, B, D, C, A. Is there another way?
A, D, B, C, A.
A, D, B, C, A.
A, B, D, C, A.
Wait. Oh, that's great.
That's all.
Is it?
That is all of them. You found them all.
The third period final?
Yes,
Alright.
but I had to tell them how many there were before they could figure it out. Okay, so these are all of the distinct circuits. Okay, I told you when you're finding distinct that you need to make sure that you start at the same letter. Okay, because watch what happens. Let's start at B. So, how can I start at B and get back to B?
B, C, D, A.
Well, one at a
B,
time.
C, D, B, B, B.
B, C, what? D, A, and back to B. B, C, D, A, back to B.
B, D.
Hold on, stop for a minute. Look, A, B, C, D, A. This and that are the same exact circuit.
Wow.
All it is I've started at a different space. They're identical though.
Clear.
This goes to A, then to B, then to C, then to D, and back. So this is why I said you must start at the same letter when you're trying to list distinct. Because if you switch it up, you can actually write a circuit that matches something you've already done.
And 4 other ways.
Okay? So I can reorder any of these to start at a different letter. If I want this one to start at D, I would go D, the next letter would be B, the next letter would be A, then C, and back to D. These are the same. I just have a different starting spot. So they call these shift Hamilton circuits because all you're doing is shifting to a different starting spot.
Are we all gonna be? We're gonna have to do that.
Yeah.
So when we learn the methods later on in this chapter, if you started at A, I may request that you take that answer and start it at D. So you would just take your answer and shift it to start at D. It's really not that bad. Okay, so look at this one right here, A, B, D, C, A. Shift this one so it starts at B.
BDCA.
B, D, C, A, B.
Okay.
Okay, so it's this circuit, this is your answer, but I just want you to shift it and start somewhere else. Okay, if I asked you to shift it and start at D, D, C, A, B, D.
I got
Okay, does that click then?
ECPC.
Question. All right, we got 4 more examples and we're finished, friends.
You said 1 page.
1 page, front and back.
You should have said front back.
Oh, should have said front and back first, Miss Smith.
I definitely my part now.
Like,
I'm definitely taking your phone, man.
Right.
And when I give it to Miss Curry and she keeps it overnight, I don't want to hear you fight.
she ain't gonna get it. I wouldn't go with it.
Okay,
I can physically take it from you. Yeah, I can do that.
and she can physically suspend you for not giving it up.
I'm gonna punch it.
Then I'll just stay at home playing Mario Kart.
I mean, by all means, my friends. But understand, I'm not helping you with anything that you missed. I know. You got
That's okay,
yourself
because you
suspended in
recorded.
my class for
That's okay,
disrespecting
because you
me.
recorded.
So. Okay, there are a total of 8 distinct Hamilton circuits in this graph. They want us to list them all. Again, if you find 1, you actually found 2
No,
because you have the reverse.
so we only have to find
So-
4.
So you technically only have to find 4. So give me 1.
D, C, E.
Up,
Bob. D.
Oh, I have to
A.
start at A. Well, you didn't say that. You should have said that first.
You
Starting
can't
at
read
vertex.
starting at vertex
No,
A,
you just said find 8 distinct.
A, B,
No,
C,
no.
D, E, F,
G,
G,
A,
A.
I, J.
I can go.
Now go backwards. A,
Okay.
B, F, E.
I can
D,
reverse
C,
it.
D, A.
A, G, F, E, D, C, B, A.
I just said that. Now we can go A, F, C, B.
Exactly.
Hold on. A, F,
No,
C.
no. Oh, I messed up.
No, you didn't.
Yeah, you did.
Oh, you can go from B.
No, you
Don't
can't
go to B though.
You can't go to B. Go to E.
Okay.
No, go to D. No, go to D. Go to D. Go to D. I'm sorry.
I don't know. What? Okay. Go to D.
Go to E.
Go to
Then
B.
B. And G. And that.
Ah.
And yeah.
So I can
and
go
rock.
A to F to C to D to E to B to G and back to A. Don't forget the reverse.
Flip it.
A, F,
Reverse.
A, G, B, E.
Q, R,
D,
S,
C,
T,
F,
W,
A.
Y, and Z. No, I know my-
Flip it and reverse it.
A, F, E, D, C, B, G, E,
You said A to F to E to D to C to B to G to
I don't like this at all.
A, F, E, D, C, B, G, A. A, G, B, C, D, E, F, A. I mean, like it or not, it's something you have to know.
I'm dropping out now.
Dropping out now? Later.
A, B,
A, B,
E, L, A.
No, wait.
A to B to E.
Okay, this is too much. To F.
I said A to G.
Exactly wrong.
I mean A to B to G
Oh,
to
no,
F
hell no.
to C
But how are you gonna get back to
to
A?
E to.
Because careful, when you go A, B, G, you block off any way to get back to A.
Right, right.
So A.
Okay, so we're good with A, B, E. Where do I need to go though?
C.
W.
F. No.
E.
Go to D.
D, C, F.
I forget that middle one. Okay, I'm gonna
Oh
do
wait, no,
G.
we already went to
No, we didn't. No, we didn't.
A, B, E, D, C, F, G,
A.
A.
And then it's backwards.
A, B, E, D, C, F, G, A.
Let's go to next quarter.
It's not from this world.
I just wrote the same thing instead of it backwards, didn't I? Wow.
A long time ago.
We got 3 more days to do.
Was born.
I think we should stop after this.
I think we should stop after this. We're almost done.
No.
Okay. So we made it through though.
Right.
I don't think I made it through.
Okay. I'm gonna tell you this. If I give you a graph this big on the test, I'm not going to ask you to list all of them. I'm going to ask you to list like 3 of them.
She's fine.
So again,
It's still a lot.
forward, reverse, and then find another one. Okay.
Oh, wait, no.
If not, you just make a letter and always use that letter. Okay. So if I have 8 total distinct Hamilton circuits starting at A, what do you think I have starting at B, C, D, E, F, and G?
Add them all.
You're gonna have 8. If you have 8 that start at A, that means I have 8 that start of every letter. Because all I have to do is take these ones and shift them to start where I want. So, again, if I have 16 that start at A, you're gonna have 16 that start at every letter. Okay? I didn't ask you to list them. I just said how many. Okay, let's take a look at this one.
No.
Find a Hamiltonian path that begins at A and ends at E. So, yes.
A, F.
So you're trying to find a Hamilton path
Got it.
that starts at A and ends at E. Remember, Hamilton says all you have to do is go to every dot once. And I need to start at A and I need to end at E.
All right.
I got it. A, F, B, C, G, D, E.
He said this.
Okay?
He said the exact
So-
same.
A to F to B to C to G to D to E.
You should just make me a teacher.
Yeah, I like that idea.
Class.
Rodrigo, you are smart, but you get too much off topic, they wouldn't learn anything.
You get to it.
And he'll sleep.
Alicia said you'd get too annoying. Right. He'd get bored and. Okay. In part B, I want you to now find a circuit. I want you to start at A and I want you to finish your circuit E A.
Oh, A,
Do the
F,
same thing.
B, C.
It's the same thing, but instead of making this my stopping point, I'm gonna continue and make a circuit. So A to F to B to C to G to D to E to A.
Hey. F
Yo,
to
add
G.
me on Clover Blues.
I got smart and put my notes over here where you can. Unless you get
So
up.
you think, yeah.
Okay? C, I want you to find me a path that begins at F and ends at G.
Got it.
Got it.
F, A, B, E, C, D, G.
Phase.
I got
Okay,
phase.
so you went F-A-B.
What? I never said
He
that.
said FBA.
Oh, my bad.
FBI. Roll.
F-B-A.
E, C, D, G.
Okay.
That's not what
So F-B-A-E-C-D-G. Did anybody use anything different?
You're lying. It's not right.
Okay, stop. Sienna, what'd you say?
A, B, E, D, and C.
Okay, so she just kind of flipped some letters around. This is still correct.
I used F-A-D-E-B-C-G.
You said you used F-A-D-E-B-C-G. That works too. F-A-D-B. E-B. All those letters. E-B-C-G.
Or even FBCEADG.
F-B-C.
FBCEADG.
That one would work as well. F-B-C-E-A-D-G. Okay, so there are multiple ways to do this, just like there were multiple ways to do Euler. Okay. Take a look at example 3. This graph has no Hamiltonian paths or circuits. Why?
Because of the bridges.
No letters.
Bridges! I love bridges.
You've got too many bridges. You've got 4 bridges in this graph. Because of those bridges, remember, once I get out to that dot, I can't go back. So I'm stuck there. So you can have a Hamiltonian path if there's only 2 bridges. But when I extend your amount of bridges to more than 2, so it's more than 2 bridges
Oh my god.
that cause this, okay? Once I extend it past 2 bridges, I no longer will never have a Hamiltonian path. I can't have any bridges if I want a Hamiltonian circuit. It'll never work because you can't get back there. Okay, you're stranded.
I'm stranded.
Alright, well, get your
All right, last one. Find all of the Hamilton circuits that start at A. Let's see if we can do it without me telling you how many there are.
W.
A, W, Q, R, S, T, U, V, W, X, Y, Z, now I know.
All right. A, C, go ahead, Sienna. F, D, E,
Whoa.
A to C to F to D to E to B to A. Don't forget to reverse it. A, B, E, D, F, C, A.
A, C, B, E, F, G, A.
A, C, B, E, F,
Go backwards. So A, B, C.
A, C, B, E, F, D, A. And reverse. A, D, F, E, B, C, A. I'll go back. Go back with something.
A, D, F.
A, D.
Oh no, A, no, A is A, D, E, F, C. Yeah. So
A, D, E, F, C, B, A.
So now go backwards. So it'd be
A, D, E, F, C, B, A. And reverse. A, B, C, F, E, D, A.
Huh?
What?
Why? That's not, no, no.
There's A.
It's A, D, F, E, B, C, A.
There's A, B, C, and D,
You said A, B, C.
A, F,
You got it, Brad.
E, D,
That's not the backwards.
A,
Yeah,
B,
that's
C.
not backwards. No, it's not. Perfectly backwards.
D, E, F, C.
All right, then there's another one, because then you can go A, D, E, F. Oh, no, wait, A, D, F, E, B, C, A. That's the backwards
Wait,
for the one.
A, D, F, E, B, C, A. We already have that as a reverse.
I'm saying A, B, C, F, E, D, A.
A, B, C, F, E, D. That's right here. That's a reverse of this one. That's it.
Right.
You found them all.
Yay.
Too much.
Okay, there are 6. So, if they want me in part B to find all the circuits that start at D, so we're going to find them.
Shift.
So we're going to shift this one. So we start at D, which means I go to E, then to B, to A, to C, to F, to D.
Exactly.
And again, reverse this. D, F, C, A, B, E, D. Okay. We're going to rewrite this one to start at D. So D, A, C, B, E, F, D. And reverse that one. So D, F, E, B, C, A, D. And we're going to rewrite my last one to start at D. So D, E, F, C, B, A, and back to D. D, E, F, C, B, A, and back to D. And of course,
No
reverse.
homework, right?
D, A, B, C, F, E, and back to D.
Is that home?
It does. However,
Do it though.
Ms. Smith is giving you your last day to work on your project.
Mario Kart.
Let's get it.
No.
Mario Project, am I right?
Project, website,
Mario Kart.
no.
Call of Duty.